This is the third video covering the homework summaries 24.6 and 24.7, questions 19 through 25 and 32. I talked about entropy quite a bit in the thermodynamics overview video, so you could take a look at that. In that video I talked about how an apple, for instance, is a source of concentrated energy, and things like dirt, maybe the apple sitting in, is not concentrated energy. So order tends toward disorder. That means that over time this orderliness of the apple will become more like the dirt. The dirt's energy is spread out, the molecules have spread out physically, and the heat energy is being released, and it can no longer be used for work. You wouldn't eat the dirt, but you might eat the apple. So that's a natural process of life, and that's what we call entropy, that all things tend toward disorder unless. So if you went to Mars, I like to ask students this: if you went to Mars and you saw this, you would probably think two things. Number one, you'd think somebody was here, right? Martians. And number two, you'd say, where'd they go? Because I don't think they are here anymore. And that's pretty obvious. If they were here, they would be keeping this thing up. So that's the answer to the question of how you can battle against entropy. So in life, the idea of entropy is that all things continue toward a greater state of entropy. And entropy is a measure of messiness. So if you have more entropy, you get more messiness, and that's just how life proceeds. Like your room, when your room gets messier and messier as you live in it, that is an increase of entropy and an increase of messiness. Now in order to stop this, or to reverse it back to order, what you have to do is you have to work, and that requires energy, right? And the problem with that is whenever you do this, you're actually creating more disorder in the universe than order. However, the good news is that that heat that you created in doing all the energy of cleaning your room will heat the atmosphere, and then it'll dissipate into space, but your room will be clean. You've at least increased the order, not of the universe, but you've increased the order of your room, and we call that a system. So your room is the room system, and you can increase the order of your room. Now you can't increase the order of the entire universe, because that's the law. The order of the entire universe is always going outward and away from the Big Bang. Now perhaps one day the Big Bang will reverse itself, gravity will bring everything back to the middle, and we will restart the process. So alright, let's see if I can go back up here. I'm unable to scroll. Come on, let me scroll. There we go. Okay, so we had questions 19 through 25 and 32. So 19, give at least two examples to distinguish between organized and disorganized energy. Gasoline versus exhaust. Apple versus dirty, smashed up apple in the dirt, organic dirt. Your clean room versus your dirty room. How much electrical energy transformed by a common light bulb becomes heat energy? And the answer is all. Everything, all energy that we use becomes heat energy. And remember, heat is just a wiggling of molecules. So even the light that hits the wall makes the wall molecules wiggle a little bit. So all the energy from your gasoline in your car also turns into heat energy in the end. Let's see, with respect to orderly and disorderly states, what do natural systems tend to do from order to disorder? And yes, they can transform to an orderly state. We just explained that if you do work on them, and it requires your energy. Physicists' term for measure of messiness is entropy. Entropy can decrease in a system if you do work on it. Second law of thermodynamics basically says we're always going to go from this high energy state to a low energy state. You can't go backwards. Exceptions occur with the second law, because we can do work on these things, but not with the first law, because energy still cannot be created nor destroyed. And then lastly, is it possible entirely to convert a given amount of heat into mechanical energy? Yes, no, absolutely not. But the opposite is true. I said that backwards. Heat to mechanical energy, no, but mechanical energy to heat, yes.